Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Black Holes and Neutron Stars, 218 mergers and counting. So what do we see here? Well, here we see images of all 218 gravitational wave events that have been detected. Now, gravitational waves were predicted by Albert Einstein in his general theory of relativity, but it took about 100 years before they were actually detected because of the technology that was needed. So the prediction was made, but no detections could be made until 2015. That doesn't mean that people weren't trying. It's simply that the small numbers you need to be able to measure here were just not able to be achieved with the equipment we had earlier. Now, how do we detect gravitational waves? Well, we use a gravitational wave telescope, and one of these is known as LIGO. And LIGO uses two different observatories, one located in Louisiana and one in Washington State, both in the United States. Two are used, even though one could detect it, but if we use two, then we can rule out any local events. And what that means is that because we are looking for such tiny variations, little environmental effects around one of the sites could give you a false detection. So it could be something as simple as a door slamming or a vehicle moving by, and that would then give you a false detection. However, the odds of the same thing happening at the same time in two widely separated locations are next to zero. So unlikely that it would occur, and that allows us, when we see them at both locations, to really be able to be confident that this is a gravitational wave event. Now, what forms gravitational waves? Well, in reality, anything with mass that moves. So you or I moving around and accelerating would cause gravitational waves. However, gravity is the weakest of the four forces of nature, and therefore gravitational waves are extremely weak and hard to detect. So in order to detect them, you need high mass objects that are moving very quickly. And the ways to detect those are through merging black holes or neutron stars. Black holes themselves or neutron stars would have relatively high mass, but when they are merging, they're swirling around each other, and just before they coalesce into a single object, they accelerate to very high speeds, and that means you have a large mass moving at a large speed, which gives you the strongest gravitational wave events. And those are some of the ones that we have detected among these 218 across the universe. Now, many of these are off in the distance, billions of light years away. And they are relatively rare events. Why do we see so many in 10 years? Well, that's because we're looking at everything in the universe and we're able to see more of them. But if we were looking for individual ones in our own galaxy, could be waiting a long time to see even one event. But when you consider the billions upon billions of galaxies in the universe, we will be able to detect them on a regular basis and really open up a new field of astronomy, of gravitational wave astronomy. Again, a new way of studying things. So we can look at it as when we started studying other regions of the spectrum and not just visible light, opening up radio waves and infrared and ultraviolet gave us a new view of the universe, and that's what we're getting with gravitational waves now. And of course, over time, the detectors will become much better, and the number of gravitational waves that we've detected will continue to grow. We can see these labeled O1 and through O4A. Those are the different observing runs. So early on, we were only detecting a handful, and the last couple of observation runs have really given us far more of these. So we can expect far more of these, allowing to us to get some better statistics and better understanding of these gravitational waves. So that was our picture of the day, titled Black Holes and Neutron Stars, 218 mergers and counting. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.